In this lesson we're going to learn how to find inverses of linear equations. An inverse is pretty simple. First of all, if you want to find the inverse of a graph, it's simply the place or the line that's graphed whenever you reflect across the y equals x line. If you're going to find the inverse of a linear equation, it's the equation you get when you switch x and y and solve for the new y. Let's take a look at how this works. Here's the graph of a linear equation. If you remember your rules for linear equations, y equals mx plus b is the form, where m is the slope, b is the y-intercept. So if we look at this equation, we notice that starting right here, it has a y-intercept of 2, that's where it crosses y, and if you go up 2 and over, or rather up 1 and over 2, this one has a slope of 1/2, up 1 over 2. So it's 1/2 x plus, and b was 2, 2. So that's my original equation of this line. I would like to find the line that is the inverse, or the one that would graph as a reflection across the y equals x line. I'm going to do that with a table here. Going over here to the left, do a little bit more. I'm going to make an XY table here. I'm just going to write down some of the points that I see on that line. Starting down at where it crosses x, down here, that looks like that's at -4, 0. And then I see a -2, and it looks like it's up to 1. And at 0, that was our y-intercept, it's 2. At 2, we're up to 3, and I guess 4 is up 4. I'm starting to see a pattern here. The y's count by 1s, the x's count by 2s. So that is my original equation here, and I'm going to find its inverse by making another xy table over here. And I'm just going to switch the x and y values. So the column that was y in the first one, I'm going to make my x's in my second table. And the column that was x, I'm going to make those y in my second table. So I just switched or swapped my x's and y's, and then these values, if I graph them, these values should make the line that is the inverse of my original equation. So when I do that, I'm going to just graph points. So I'm going to go down 0, 4, 1, -2, 2, 0, 3, 2, and 4, 4. And when I connect those with a line, I've already done that, it looks like this. So my green line is that line that I just defined, so you can see that it does look like it's probably a reflection. Remember, the y equals x line is the line that goes through the origin, 0, 0, and has a slope of 1. So I drew that in as a dotted line here for you. And as you can see, this line, y equals (1/2 x plus 2), that's my original line. Then the line up here in green, let's see, what is that? That one looks like it crosses down here at -4. So this line is y equals slope up 1, or up 2 over 1. So it has a slope of 2. So y equals 2x minus 4. That looks like that is the line that is the inverse, and of course this dotted line is my y equals x line. And the y equals 2x minus 4 line is a reflection, the same distance to each point from the dotted line, and it's a reflection over the y equals x line. Now those are pretty easy because we can look at the graph and we can find the points and switch the points, but we would like an algebraic way to find these without having to each time go in and switch points and do all of that stuff, and we'd like to be able to just find it rather simply with algebra. So let's take a look at how you would actually find these using algebraic methods instead of having to graph it every time. So here's the same equation, our original y equals 1/2 x plus 2. In order to find this algebraically, we simply switch the x and y values and solve for the new y. So I'm going to rewrite this equation. Y equals 1/2, or rather x equals 1/2 y plus 2. So I have switched my x and y values. And now I'm just going to solve this for y. So I'm going to move 2 over, subtract it from x. That leaves 1/2 y on the right. And now to get rid of the 2, I'm simply going to multiply both sides. Be sure you do the whole side on the left by 2. Distribute that, 2x minus 4. And of course the 1/2 and the 2 cancel, leaving just y. And so I'm going to write this in function notation. The little -1 right here means inverse. So you read this, the f inverse of x is equal to 2x minus 4. So we found the inverse, and you notice that this inverse is the same equation that we came up with when we did it graphically. Let's do one more just to be sure we have the hang of it. Here's another linear equation, y equals 4x minus 8. It still has the slope of 4 and this time a y-intercept of -8, but it's still in the mx plus b form. If it were not, you could put it in that form, or you could just solve it from whatever form you have it in, because the only thing we do here is we switch x and y. So I'm going to make yx, and I'm going to make xy, and now I'm going to solve this equation for y. So again, I'm going to move 8 over and add to x, leaving 4y on this side. And this time I'm going to divide by 4 on both sides. Of course, those 4's will cancel, leaving just y over here. And then, remember that's assumed to be a 1. That's 1 divided by 4. Probably easiest just to write it 1/4 x. And 8 divided by 4, don't forget to divide all the parts, or all the terms. 8 divided by 4 is 2. So again, I'm going to write it in function notation, the f inverse of x, that's what -1 means up there, equals 1/4 x plus 2. And we have found the inverse, or the equation of the inverse. Inverses are not hard, inverses of linear equations in particular. It's just finding an equation that will reflect over the y equals x line, or if you're doing it algebraically, switching your x and y and solving for the new y. If you'd like to have lessons on other topics, you can go to www.mymatheducation.com, or you can just look up My Math Education here on YouTube, and you can get more lessons there. Thank you for watching. Hope you'll come back. Hope you'll subscribe to the channel if you want more math lessons.